All right. So today we're going to factor our trinomial ax squared plus bx plus c. But today a is not equal to 1. Yesterday when a was equal to 1, really what we needed to do was find the two numbers that multiplied to c and added to b, and then we could set up our parentheses. Or the cross helped us to organize that, or the box helped us to organize it and come up with what goes in our parentheses. Well, today we have the same idea. We're still going to use a cross, but for when a is not 1, the box really becomes very important. And we'll learn one other technique for doing this, that's just a slightly different thing. But the purpose, the point, the goal is still always the same thing, to be able to factor this into two things that are multiplying by each other. So our first step, when a is not equal to 1, so we have some number in front of the x squared, we always need to look for a greatest common factor between a, b, and c. Is there some number that divides all three, a, b, and c? And if so, we need to factor that greatest common factor out. So for example, if I had 6x squared plus 4x plus 2, what I would always, or my first step is always going to be to say, is there some number that goes into all three of 6, 4, and 2? Is there such a number? Yes, what is it? 2. So we're going to bring that to the front and say this is 2 times 3x squared plus 2x plus 1. So our first step is always to factor out that greatest common factor, if there is one. And then our next step is going to be, we'll go to the cross and box, or the other technique that we'll use, which has a really interesting name. It's called slip and slide. All right, so I just want to start out looking at some examples, because we did the cross and box yesterday a lot, and the process of doing the cross and box that we're going to do today is the same thing. So we want to factor 3x squared plus 7x plus 2. So this one gets a little more complicated because of this 3 in front of the x squared. Now the old school way that I would do this is I would say, well, the only way to get a 3x squared when I multiply my two parentheses together is to have a 3x and an x. Because 3 is prime. 3 and 1 are the only factors. And then I would say, well, the only way to get a 2 is a 1 and a 2. So this either has to be a 1 here and a 2 here, or a 2 here and a 1 there. In order to get 7, I'd say, well, I need 3 times 2 is 6, plus 1 is 7. So that's how I would do it in kind of the old school way. But there's a little more to figure out, because this 3 is multiplying this 2. There's more going on. So, a way that will help us keep this organized, we'll make the cross. For the cross here, we're going to do it like we did yesterday, a, b, and c. We start by multiplying a times c. A times c is 6. And that is what goes up here in the top of the cross, is this 6. And then b still goes down here, 7. So now we go to our factors. We want two numbers that multiply to 6 and add to 7. And since both of these are positive, I know that my factors have to be positive and positive, because the only way to get a positive number when I multiply is either positive, positive, or negative, negative. And since this that we're adding to is positive, it can't be negative, negative to add to positive 7. Well, we could list our factors, but I hope we can see this. What are two numbers that multiply to 6 and add to 7? Well, if we're not sure, let's look at our factors of 6. Factors of 6 are 1 times 6. Oh. 1 times 6 is 6, and 1 plus 6 is 7. So this is going to be a 6 and a 1. Now, because this number isn't a 1 here, I can't set up my parentheses straight from here. Now I need to make my box. And we're going to set up the box just like we did yesterday. Up here goes 3x squared. Down here goes 2. In this box goes one factor times x. And this box, the other factor, times x. And now we take out our greatest common factors. So what's the biggest number that goes into both 1 and 2? 1. And these don't share any x's, so I don't bring out an x. Here, what's the biggest number that goes into 3 and 6? 3. And what's the smallest x that these two share? 1x. Do the same thing here. Biggest number that goes into 3 and 1? 1. Smallest x that these two share? 1x. Biggest number that goes into both 2 and 6? 2. And they don't share any x's. So this tells me my parentheses are x plus 2 times 3x plus 1. So I have to set up my box here when a is not equal to 1 and take out my greatest common factors to get my two parentheses. But the start of the problem is the same. We multiply a times c. That goes here. Yesterday, because a was 1, all that went here was the last number. But today, since the a is not 1, we get something different there. But then the process is the same. All right, so questions here. Yes? No, doesn't matter. Since we're multiplying, it doesn't matter. All right, so let me show you the slip and slide method now. 3x plus 2 plus 7x plus 2. For the slip and slide method, we're still going to multiply a times c. But the way we're going to think about this is this 3 is going to slip over here and multiply. So we're thinking of moving the 3 here to the end. So I'm going to write x squared plus 7x plus 3 times 2 is 6. And now I'm going to factor this. So this is like what we did yesterday with a equal to 1. And our factors of 6, that add up to 7, we know are 1 and 6 already. If we started out doing this, we'd have to figure out that our factors were 1 and 6. So this is going to be x plus 1 times x plus 6. Well, here we multiplied by 3, so we're going to undo that by now dividing by 3. And then when we get here, we need to reduce the fractions if we can. Well, 3 divided by 6 is 2. And if I can't reduce this fraction, this is where the slide comes in. The 3 slides over here in front of the x. So this becomes 3x plus 1, and this becomes x plus 2. And we get the same thing that we got before. Yes?
And you split it over because one is divisible by 2.
Yes, if it can't be reduced, if we can't reduce this fraction, then whatever's in the bottom slides over in front of the x.
And you want to reduce it so it comes out even. You don't want another fraction, right?
Well, if this were, yes, if you could reduce the fraction, you reduce it first, and if you still have a fraction, then you still slide it over.
Right.
Yes. All right, and this method is what we call slip and slide. This is the cross and box. This is slip and slide. The cross and box is kind of like Old Faithful. Pretty much anybody that talks about factoring knows about the cross and box, except maybe someone who learned in the dinosaur days. That would be me. We never did the cross and box when I was in school.
Which one do you like better?
I always do this. Just figure out how the numbers work. But I like slip and slide as what there's a lot of different kind of tricks that you can use. Slip and slide seemed like the one that had the least steps that were easiest to remember, to me anyway. All right, let's look at another one.
Mr. Beaver,
Yes?
what happened to 7x?
7x, well, this is what you get when you have x times 6 plus 1 times x. That's where you get the 7x.
Oh.
So we don't ever do anything with the 7x. The only thing that 7 helps us with is we need the two numbers that we come up with here to add up to 7.
Okay.
All right, let's look at another example. 2x squared minus x minus 3. Well, the first thing we should always think, and I think I forgot to mention it on the last one, is there one number that goes into both 2, 1, and 3? It's just 1, so I don't need to pull the 1 greatest common factor out. We're good here. Now, the way I would do this one is I would say, well, in order to get 2x squared, I have to have a 2x and an x. And in order to have a 3, it either has to be 3 and 1 or 1 and 3. And then I figure out which one it's going to have to be to get the numbers to work out the way I want. And for this one, it turns out to be 3 and 1. 2 times 1 is 2. Minus 3 is negative 1. So it has to be minus 3 and a positive 1. That's how I think about these. We're going to use a cross and box or slip and slide to help us out. Well, here is A, there's B, and there's C. A times C is negative 6. 2 times negative 3 is negative 6. So let's set up our cross. Negative 6 goes there. That's what we're going to multiply to. This is negative 1. That's what we're going to add to. So now we need two numbers that multiply to negative 6 and add to negative 1. And the only way I get a negative when I multiply two numbers together is one needs to be positive and one needs to be negative. It's the only way I get a negative number when I multiply two numbers together. So we just have to figure out which ones work to add to negative 1. Well, let's list our factors of 6. 1 times 6. Well, 1 minus 6 is negative 5, and 6 minus 1 is positive 5. So that doesn't give us a negative 1. 2 times 3. Negative 2 plus 3 is positive 1. 2 minus 3. Negative 1. We're going to use those. And we have to have a minus 3 and a plus 2. So let's set up our box. Two x squared goes here. Negative 3 goes here. Factor times x goes here. The other factor times x goes here. And now we're going to take out our greatest common factors. Biggest number that goes into both 2 and 3? 1. They don't share an x, so that's 1. Biggest number that goes into 2 and 3? 1 again. The smallest x that both of these have? 1x. Biggest number that goes into 2 and 2? 2. The smallest x that both of these have? X. Biggest number that goes into 3 and 3 is 3. And because this is negative, we're going to make that a negative 3. They don't share an x. So my parentheses are x plus 1 times 2x minus 3. And let's do the slip and slide method. So 2x squared minus x minus 3. I'm going to slip this 2 over and multiply. So I get x squared minus x minus 6. Now we are still at two numbers that multiply to negative 6 and add to negative 1. We always have to figure that out when we're factoring. Well, we already figured out that that was negative 3 and 2. If we had started out with this, we'd have to do this process to figure out these two numbers. X minus 3, x plus 2. Well, we multiplied by 2, so we're going to undo that by dividing by 2. 3 halves, we can't reduce that. So we're going to slide that over. 2x minus 3. 2 divided by 2 is 1. All right, questions there? All right, let's look at another one. All right, the first thing we want to do is check for a GCF. Is there some number that goes into 2, 13, and 24? Just one, because 13 is prime, so we don't need to factor out a GCF. There's A, there's B, and there's C. When the numbers start getting bigger here, then it starts getting trickier doing it kind of the old way. because 24, there's quite a few more factors. I'm just going to go straight to the cross and box here. A times c, 2 times negative 24 is negative 48. Now I know that the only way to get, now we'll set up our cross. Negative 48. We need it to multiply to negative 48, and we need it to add to negative 13. The only way to get a negative number when I multiply is one has to be positive and one has to be negative, plus and minus. It's the only way we can get a negative number. So we're looking for things that multiply to negative 48 and add to negative 13. Well, 48 is bigger, so there's quite a few more factors. So 48, we'll factor that. 1 times 48. We're not going to get 13 out of that. 2 and 24. We're not going to get 13 out of that. 4 and 12. We're not going to get 13 out of that. 8 and 6. Oh, we're close. 8 and 6 is 14, but that doesn't help us out. Yeah. 16. 3 times 16 is 48. And we can say 3 minus 16 is negative 13. Yes?
I'm just a little confused. Why did you multiply A and C? They're not like times.
So for factoring, we always multiply A times C.
Okay.
That's where this number comes from.
And then-
Yesterday, because A was 1, this number always just turned out to be what was here.
Okay.
But we always multiply A times C to get this number.
Okay.
Okay? So there are a few more factors of 48 that we had to go through to get our factors here. And 3 minus 16 is negative 13. Now we set up our box. Two x squared, negative 24, factor times x, other factor times x. And now we're going to take out our greatest common factors. Biggest number that goes into both 16 and 24? 8. And because this is negative, we're going to take out a negative. This way, let's do this one first. Biggest number that goes into 2 and 3? 1. And the smallest x that's in both of these? 1x. Here, the biggest number that goes into 2 and 16? 2. And the smallest x here? 1x. Biggest number that goes into 3 and 24? 3 goes into 24, and they don't have an x here. So we end up with 2x minus 3. Sorry, plus 3. Times x minus 8. So a little more here, because when the numbers get bigger, there are more factors, and when the numbers get bigger, it's a little trickier to find the greatest common factor. All right, let's look at slip and slide. Two x squared minus 13x minus 24. We're going to slip this over. 2 times negative 24. X squared minus 13x minus 48. So even with slip and slide, still we're multiplying A times C. We're getting this negative 48, just like we did here. So we're still looking for two numbers that multiply to negative 48 and add to negative 13. So we're still doing the same thing here. It's just a different format. So if we started out here, we would go through this process to pick 3 and negative 16 for our factors. So we would factor this polynomial this way. Well, we multiplied by 2, so we're going to divide by 2. And then we're going to reduce if we can. And if not, we're going to slide this over. 2x plus 3. And 16 divided by 2 is 8. And just like yesterday, we can always check to see if we did this correctly by multiplying this out. If you multiply it out, you should get back to where you started. All right, questions on that example? Okay, let's do one last example. 30x squared plus 14x minus 8. So the first thing that we should do is check for a greatest common factor. Is there a number that will go into all of 30, 14, and 8? 2 goes into all of 13, 40, 14, and 8. So we're going to say this equals 2 times 15x squared plus 7x minus 4. And we're going to factor this. And we're just going to leave this 2 out in front, multiplying everything that we come up with. Well, these numbers end up kind of big. This one would be difficult to do kind of the old school way. Here, that's A, that's B, and that's C. A times C is negative 60. 15 times negative 4 is negative 60. It's negative, so one has to be positive, one has to be negative. That's the only way I can get a negative 60. So I know one is positive and one is negative. This is negative 60. We want our numbers to multiply to that and add to 7. So let's find our factors of 60. And we need them to add to 7 with one positive and one negative. All right, so my factors of 60, 1 times 60. There are a lot of factors of 60. 2 times 30. 3 times 20. 4 times 15. Still not getting anything that adds or subtracts to give me 7. 5 times 12. Yes. 12 minus 5 is 7. So those are our factors. You have to have a negative 5 and a positive 12. So we'll set up our box. Uh, 15x squared here, and a negative 4 here, factor x here, factor x there, factor out a GCF. Biggest number that goes into 4 and 12. Four, there we go. And they don't share an x. Biggest number that goes into 5 and 15. 5, the smallest x here. X, 1x. Biggest number that goes into both 15 and 12? 3. Because 3 times 5 is 15, 3 times 4 is 12. Smallest x is x. Biggest number that goes into both 5 and 4? 1. And because this is negative, we make that negative. So my parentheses are 3x minus 1 times 5x plus 4. But here I've multiplied by 2, so my final answer is 2 times 3x minus 1 times 5x plus 4. Because I still have this 2, I factored this to get this. I still need to have that 2 out front. All right, now let's look at slip and slide on this. 15x squared plus 7x minus 4. I multiply these two 15 times, and I get x squared plus 7x minus 60. So I'm still looking for, when I do this, I'm still looking for two numbers that multiply to negative 60 and add to 7. So finding my factors turns out to be exactly the same here. So I would set up this cross for this problem. So I would still get x minus 5, and I'd get an x plus 12 when I set up my cross for this problem. Well, I've multiplied by 15. So I need to divide by 15. And now I need to reduce my fractions. Well, 5 over 15 reduces to 1 over 5. And 12 over 15, I can divide both of those by 3. That reduces to 3 over 5, 4 over 5. I can divide both of these by 3, and that 12 over 15 reduces to 4 over 5. And now I need to slide the 5. This should be 3. 15 divided by 5 is 3. Thank you. I need to divide the 3 over, slide the 3 over and slide the 5 over. 3x minus 1 and 5x plus 4. And then at the end, I need to remember I factored this thing that's inside the parentheses. So my final answer is 2 times 3x minus 1 times 5x plus 4. So this is one where we had to reduce the fractions and slide over on both sets of parentheses. Yes.
For the thing you're trying to find, like what can multiply and add into the two numbers, is there always going to be something? Because if there isn't something, then it would just be the 1 times whatever. Is that?
Yes, and it is possible. It is possible that we end up with a 3-term polynomial that can't be factored. That is possible also. And I think that the ones that we give you can be factored, but not every single thing like this can be factored.
And we'll get more into that later in spring.
Yes, when we talk about solving equations, because that tells us something about the equation. All right, that was a good, very good question. All right, anything that you want to add or suggest, Ms. Linder?
Now just remember to take out that GCF and then add it back in at the end of your final answer.
Right.
So that you went through.
All right, our homework. This is in section 8.6, page 521. Eight through 26 even. 37, 38, 40, and 51.